Ida. Hello. You're muted, Del.
I can hear you. 1 second.
Good evening, sir.
Very good evening. How are you?
Fine, sir.
Nitish, how are you? So all are fine. Tharn, can you hear me?
Good evening, sir.
Very good evening. How
Sir,
are
you're
you?
audible, sir.
Good evening, sir.
Very good evening. So that means all of you are audible to me, right?
Yes, sir.
Okay, so let me share the screen. So can you first let me know that have you revised the previous class?
Yes, sir. Yes, sir.
Okay, so tell me that is this board visible to you?
You didn't share anything.
I have
No, sir,
shared.
it's not.
Yes, sir. Yes. Yeah, sure.
Is it now visible?
No, sir.
You didn't
Now?
share anything.
Yes, sir. Now it's visible.
Okay. So we have discussed all the types of reactions, right?
Yes, sir.
Yes, sir.
Now we are
Yes,
left
sir.
with exactly. We are now left with exothermic and
Sir, the
endothermic reaction.
board is actually not visible. Like it's a blank
It's
screen.
just a blue screen.
Board is not visible.
Yes, sir.
Yes,
It
sir.
only showed that the share screens.
I hope it should be visible to you. Okay, let me write it here first of all.
It didn't share anything. It's a house.
Is it now visible?
No, sir.
No, sir.
Should be visible to you. I have written here. Okay, I'm writing it now. Exothermic reaction.
No, sir. We can't see anything.
No.
Why?
Sir, can you re-share your screen?
Okay, sure.
Now something is in the middle, sir. Now you stop.
Had a haircut.
Yes, sir. I still have the more hand.
Yeah, is it now visible?
Yes, sir.
No,
Yeah, so
no,
I-
sir.
No, no,
No,
sir.
sir. You didn't
No,
share
no,
anything
sir.
yet.
It's
Sorry,
not.
sorry. You didn't share anything yet, sir.
exothermic reaction. Is it now visible?
Sir, you didn't
No,
share.
sir. You didn't even share your
Didn't even
screen.
share anything, sir.
Yes.
But I have shared here from mine
Sir,
side.
Tarun is there?
I already shared.
No,
Sir,
sir.
it's, there's only speakers videos now, sir.
Wait.
Yeah, now only taking exothermic endothermic reaction that you asked. Exothermic endothermic reactions in the assignments also.
We didn't complete it yet.
Yeah, we didn't
Yes,
complete yet. Okay, so tell me now, is it now visible? So if I
No,
will
sir.
write some,
It's not visible, sir. It's
but
visible.
from my, okay, I will just, if I will just choose this one color. So tell me now, is it visible if I will write here something?
No, sir.
Is it not visible?
No, sir.
No,
It's
sir,
not
it's not.
visible, sir.
Okay. What I can do now.
Now it is visible, sir.
Yes, sir.
Sir, now we can see a screen, sir.
Okay, now you can see the screen.
Sir.
Is it now visible?
Yes, sir.
Yes, sir. Yes, sir.
Okay, so if I will write something here, is it visible?
Yes, sir.
Okay, that's fine. So tell me now that we are just going to study the exothermic reaction, right? So can you tell me what is an exothermic reaction?
Chemical reaction with evolution of heat
Exactly. Any such reaction in which there is
produces
no,
heat or something like that.
Yes, sir.
Evolution of heat.
exactly. I will
Yes,
write it here.
heat given out.
In which heat energy is evolved, right?
Given out.
Yes, sir.
So you didn't teach this yet, right, sir?
Yeah.
He didn't. He didn't.
Yeah,
Yeah, I
but the
haven't.
question came in the worksheet, sir, like the
That's
assignment.
what I also asked.
Maybe they have asked this, but you should remember that any such reaction in which heat energy is evolved, so that is your
Sir, I asked
exothermic
for
reaction.
examples, sir. That's
Yeah, I will just give the example of this exothermic reaction. For example, if we are just having this carbon and I'm just burning it in presence of oxygen, so what will be the product?
carbon dioxide.
Exactly. So will there be only carbon dioxide or will there be any heat evolved?
Heat.
Heat
Exactly.
evolves.
Yes, heat and light energy is evolved
Plus.
here. So that means this reaction is your exothermic reaction, isn't it?
Yes, sir.
Yes, sir.
So any doubt here?
No, sir.
No, sir.
Yeah. So can you give me more examples of this exothermic reaction?
Sir,
Formation of ammonia.
yeah.
Yes, formation of
N
ammonia.
plus N plus
Yes,
H3. Sorry, H2.
N2 plus H2.
N2 plus
Yeah,
H2. So it
N2
will
plus H.
just give
Nitrogen
you
plus hydrogen. Yeah.
ammonia, right?
Ammonia.
NH3.
NH.
NH3. So it's also
Yes.
your what? It's also your
Sir, it's not
exothermic.
balanced.
Sir,
Sir,
3H2, sir.
3H2.
Sir,
Sir, it's 3H2.
3H2.
Exactly. In order to balance, we'll write here thrice H2,
Yes,
right?
sir.
Okay, one more example. So can you give me one more example of this exothermic reaction?
Formation of water.
Formation
I
of
don't think that's exothermic.
Water.
Magnesium
that is endothermic. Mm. When we actually decompose water, okay, formation of water, right?
Sir, H2 plus O2 gives H2O with some heat evolved.
Yes. Similarly, for example, if we will just write this methane, it is our fuel. So I will burn it in presence of oxygen. So what I will get? Carbon dioxide plus water.
Ethanol.
Sir, every
Oh,
H4
wait.
has like atomic or exothermic. Sorry, H2O.
Sir, this is a neutralization reaction. No, wait. No. Sorry. This is not.
This is a
It's not.
combustion
Sir,
reaction. This
CO2 should be a salt, right?
CO2 is not a salt.
If it's a salt, it's a neutralization. Yeah.
So this is your combustion reaction.
Yes,
So
sir.
it is also an exothermic reaction, right?
How
Have you
is
got it?
CO2 a salt?
Salt,
CO2
I
is
said
not
if it's a salt.
CO2 is not a salt. Salt is that which contains ionic bond. For example, NaCl,
I
it is
said
your salt.
liquid if it's salt, sir.
Just your sodium sulfate, it's your salt. So carbon dioxide cannot be your salt, right?
Yes.
Okay, can you balance this reaction?
Sir, see.
So you have
Sir,
to put
2
2 at the H2O, sir. You have to put the
2H2O,
2 at
that's it.
H2O, sir.
2H2O and then O2,
No.
Yeah, 2O2 today, not O22.
2O2.
Oh yeah, sorry.
O2.
Yeah,
Same
2O2, sir.
2 over there. 2
Right, exactly. It is now balanced, right?
Yes,
Yes,
sir.
sir.
2O2.
All these reactions, they are your exothermic reactions. For example, if I will write, let's say I'm having ethane, that's C2H6, right?
Yes, sir.
It is known as
Sir.
ethane. Now, can you tell me this ethane, if I will burn it in excess of oxygen air, what I will get the product?
So carbon and water.
We will
Or
get, yeah,
carbon dioxide and
dioxide and water, and we will also get the heat energy.
H2O plus heat energy.
4H2O.
Sir, but isn't this
that's
the
it.
same Sir, but isn't this the
No.
same product as CH plus 2 O2, sir? CH4 plus O2.
Yeah, that is also the combustion reaction, but that was methane. Now it is ethane. So this another organic
Sir, but
compound.
so both when we heat it, we get the same products.
Yeah, exactly. Because both are our fuels and both are our alkanes. So when we just burn them in excess of oxygen, we get the same product. That's carbon dioxide and water, right? Now, can you balance this?
So you have to put a 3
the two
H next to H2O and 2 next to a 3 next to a O2, sir.
So
No, sir,
twice,
Yeah,
Hey, it is the correct one.
3 there
3 there.
and 3
Yeah.
next to that O2, sir.
Which one?
So once. Wait.
Sir, I thought it was
Four.
H, sir. What do you mean, sir?
It is heat at
Sir,
EET.
C2
Sir, you have to
H6
put
plus
5 next to that
4O2.
O2, sir. You have to put 5 next to that O2.
5, what do you mean? That give us 10.
Yeah, there are. Yeah, that means there are 2 H.
Sir,
5
what
into
is
2 is
CH4?
10.
It's carbon
Plus 3
hydride.
is not 10, sir. It's 7, sir.
Just
So
try
what's
to balance this.
CH4?
2 into 2
CH4 is
is 4. 3
methane.
into 2 is 6.
CH4
Okay,
is
sir.
your methane and
Okay,
C2H6 that's your ethane. Yeah.
C2 H6 plus, 1 second, sir.
How many oxygens I will write here?
So
Sir,
5,
7
sir.
by 2. 7 by
No,
2.
exactly. You can write 7
sir.
by 2, but that is not the better way to balance. So can you tell me, you have to remove this fraction. I have already told you.
And multiply everything by 2. So it will be
Ex-
C4.
How did
exactly.
you
You
get
will just
7 by 2, sir?
multiply the
Because
whole
of the side
equation
there
by
is
2.
7.
You multiply the whole with 2.
I told
The
that
side there is 7.
whenever you have such fraction balanced reaction, you will just multiply whole equation by 2. So what I will get finally, so I will write it
So
here that I will get twice
C4H12
C2. Yeah.
7O2
Plus 7O2.
or 7O2 and then 4CO. No, wait. 4CO.
Yeah, it is 4CO2 plus
4CO2 plus
6H2O.
6H2O.
plus heat.
That's it. Plus 2 heat.
Sir, but how did you get 7 by 2, sir?
See that 2O2 is 4.
So I will write
3O2.
here 4 and I will write here 6. So is it now balanced? Can you
Yes.
check it
Yes,
once
sir.
Sir,
again?
I don't understand how you got 7 by 2, sir.
See, 2 was there for O2. So O2 will become O4. And then
It is
the O is
easy.
in the
Just
H2O.
multiply the whole equation by 2. So that's why it will now become twice C2H6 and 7 times O2 and 4 times CO2 and 6 times H2O. Any doubt here?
Yes,
No,
I
sir.
have a doubt. I don't understand how you got a fraction there.
See,
Okay, you
Because you
don't
need
got
to watch the videos in which you are absent on, which you didn't.
no, he was present.
I
He was
watched
present.
everything.
Okay, no problem. I will just repeat it on the
Did.
next page.
1 second, sir.
Hey,
Oh,
in
okay.
this side there is 7. 7 you can't get by multiplying that. So they put 7 by 2.
See, it was just like this. We were having C2H6, right?
Yes, sir.
Then it was plus O2. It gives us CO2 and then water. Now we have to just balance this. See what we will do. There are 2 carbon atoms on the reactant side, so I will multiply here it by 2. Then there were 6 hydrogen on the reactant side, so I will multiply it by 3. So 3 to 6. Now how many total oxygens we are having on the product side? Can you tell me?
7.
Sir, 7, sir.
Exactly 7 oxygen. So now if I will multiply it by 3, so 3 twos are 6, so that means it is not becoming 7. If I will multiply it by 4, 4 twos are 8, so it is still not becoming 7. So what I will do, I will just multiply it by 7. 7 twos are 14, so 14 upon 2, so that is 7. So it is now balanced.
Okay.
But it
Yes,
is
yes,
fraction.
I get it.
We have to remove the
Sir,
fraction.
2C2, sir. Yeah.
Yeah,
So
in
first
order
you have to multiply, then only you get 2C2.
then you will now you will multiply the whole equation by 2, so it will now finally become twice C2H6. Then it will be now 7 times O2, and then it will give you 4 times CO2 and 6 times H2. Got it now?
Yes, sir.
So all these reactions, they They are your exothermic reaction, right?
Exothermic.
Can
Okay.
you go to the
Now,
previous slide? I'll just copy it.
no, here I can't go to the previous slide. This is
There's
the.
Okay, sir.
And
But I will just share the PDF of the class after we will finish this class.
Yes, I'll
Okay,
just
sir.
copy down this equation.
Yeah, you just keep writing whatever I write here.
Can you just,
So
is there any other equation, sir?
am I audible?
Yes, sir.
Yes, sir.
So what happened to the reaction?
You have not written down.
Oh man, sir.
I will write it again. That reaction
No
was
need, sir.
like,
No need, sir.
okay, no need.
So,
Then let
yeah,
can write my own.
I'll tell him later, sir. I'll tell him later.
okay, right.
I
So
know
then
I know it.
endothermic reaction. So can you now tell me what is an endothermic reaction?
Sir,
So,
Sir,
yeah,
reaction that absorbs heat.
Absorbs heat energy.
Yeah, so it is that type of reaction in which heat energy is absorbed, right?
Yes,
Sir.
sir.
In which heat energy is absorbed. So that is known as endothermic reaction. So can you give me the example?
Sir, hydrogen
Water
plus
can also-
oxygen. So I think hydrogen plus oxygen, one of it is endothermic. Is it?
Yeah, hydrogen.
Carbon
I-
plus water. Will give.
See, if I'm writing carbon with the sulfur, so it will give me the carbon sulfide. This reaction is your endothermic reaction. So that means heat energy is here absorbed. So that means this reaction takes place in presence of heat, right?
So it's 2S.
Yeah, exactly. You can balance. So it's twice S, 2S. Okay. For example, if I'm
Sir.
now having, yeah,
Elephant toothpaste is exothermic reaction, right?
Elephant toothpaste.
Yeah, you
yes,
don't know that.
formation of elephant
I
toothpaste.
know.
Mr. Beast video.
So see now here, calcium carbonate. If I will just heat it, what I will get? Calcium oxide and
Sir, calcium oxide and carbon dioxide.
But isn't formation of water also a endothermic reaction?
okay, I will write it here. See, we are having this H2 plus O2, right?
Yes, sir.
We will get here this water. So exactly, it is also your, it is exothermic reaction, not the endothermic.
Oh, sorry.
Liar.
I will write it here
I
that
didn't
this
lie.
one
I
is
didn't know it.
exothermic. But if I will write like this, that I'm having this water, and then it is I'm passing the electricity, that is the electric current, right?
Yes, sir. Yes, sir.
Then it becomes H2 plus O2. So this is your endothermic.
Endothermic.
Exactly, this is
Sir,
your
how is
endothermic.
electricity endothermic?
Electrolysis,
It
like
gives heat.
we learn.
If electricity
We
hits you,
learned
you'll
this
burn.
in school.
See what actually we are doing here. We are just doing the electrolysis of water. That means the water will not break itself. We have to give some energy to the water, right? We have to give,
sir.
and that means energy is absorbed. And what energy is here absorbed? That is the electrical energy. So that means first we have to give the electrical energy to the water, then it will decompose to H2 plus O2. So this is also your endothermic.
Okay, sir. Sir, zinc sulfate on heating.
Yes. Okay, zinc carbonate on heating, not the sulfate. Zinc carbonate, if we will just heat, it is also
But that
your
is also
endothermic.
endothermic, right? Zinc sulfate is also endothermic, right?
Exactly, it's also your endothermic. So have
Sir,
you
can
noted
you
down?
keep the slide? 1 second, sir. We'll note it.
Okay, okay, note down.
I am done.
No writing while teasing. Bad boy.
Singer.
You're a bad boy.
Yeah. So don't erase it, sir, without us telling us.
Have you noted
So
down
what?
now? Yes.
Yes, I'm done, sir. So blue vitriol on heating.
No, I
Yes,
don't think
definitely
that's
we will see it on the next page. You just finish this first.
So it's fine. I'm just asking.
No, what happened?
Have you noted down this?
Last one,
Yes,
sir.
sir.
1 second, sir.
Yes, sir.
Hey,
You can go
no,
to the next
don't-
page, sir.
don't
Don't
betray
listen
me.
to like that, sir.
Uncle.
You were writing before me, da.
No, I wasn't. I was waiting for
You
sir to
were.
finish.
Okay, until
Okay,
that,
I
then I will write here below the blue vitriol, which you are telling. So we are having this copper sulfate pentahydrate. This is known as your blue vitriol, and when we will just heat it, it is also an example of endothermic reaction.
Copper plus sulfate plus water.
Yes, plus 5 times water, exactly.
Sir, done, sir.
Okay, write yourself plus 5 times water.
5 times
So
water
blue
is
vitriol with the 5H2O is also a
Hey, blue
endothermic.
vitriol
Blue
is
vitriol with
CuSO4 dot
5H2O.
5
Sorry,
soda.
sorry.
I don't know what you're doing in school.
Or in class.
I didn't listen anything in school.
You're just
So
making
I have
fun of
noted
us.
down this now.
Self-deprivation.
Yes, sir. Done. So you can erase.
Just 1
everything.
second, so one. Is this endothermic,
One
right?
second.
Yeah, that's endothermic.
Okay, so whether it is blue vitriol, whether it is white vitriol, or whether it is green vitriol. For example, if I will write FeSO4, it is your green vitriol. If I will heat it, what I will get?
Sir, FeSO4.
Sir, FeSO4 plus H2O.
Plus 7
Oh.
times H2. Yeah. So this is also your which reaction?
Endothermic.
Say
Exactly.
endothermic.
Exactly, endothermic reaction.
Is
Okay, now
endothermic
sometimes,
as well as
yeah. So
decomposition reaction.
sometimes question is asked that give the example of reaction in which light is absorbed. So can you tell me the example of reaction in which
AgCl.
light?
AgCl on
Okay,
heating.
AG.
AgCl on heating.
Exactly,
Water
exactly.
also.
Sorry, not heating.
Oh, wait,
On
that's
passing
electricity.
light.
Passing, yeah.
So if we are having
Gives
silver chloride,
Heating,
we will
not
just
heating.
give light
Ag
on
plus
this.
Cl, sir. Ag
We will
plus Cl.
give, yeah, it gives you Ag plus Cl2. So you can balance it twice and twice. So
Silver
similarly,
bromide.
photosynthesis. Photosynthesis is also an example of such a reaction in which light
The
is absorbed, right?
CO2
Plus
Okay.
H2O gives
water on sunlight.
Water and
C2H6O2.
glucose.
No,
Water
So in presence of
C6H12O6.
chlorophyll and sunlight.
C6H12O6.
Hey, I said the same thing. You said no and said the same thing now. What is this? Now?
You said C2
Oh, okay,
So can you
sorry.
balance this?
plus oxygen.
Sir,
Sir,
C6H12O6 is
Sir, we already
basically
balanced this one.
glucose, right?
No, it's not.
Yeah, it is your
6CO2.
glucose.
Sir, 6CO2
You said no.
plus
Yes,
6H2O
CO2.
gives C6H12O6 plus, I don't know,
It's
6
so
times
hard, sir.
water.
6H2O plus
2 times
Like
C6H12.
2O2.
No,
No, 2O2.
it's 6 there.
6O2.
It's done. It's done.
Is it now balanced?
6O2.
Can you
How?
try? Can you
It is balanced, sir.
exactly? It is now
12
balanced.
plus 6,
No,
18.
but
Then
isn't
12 plus 6, 18.
sir,
Yeah.
Fe green vitriol when absorbs heat, it becomes FeSO4 plus 7H2O, right? So, but isn't that also a decomposition reaction?
It is the.
Yeah,
Who
we have
said
already
no?
So
the
these
decomposition.
reactions are a type of decomposition reactions.
No,
No.
We have already
Yeah,
studied this as an example in thermochemical decomposition. Why don't you remember?
Yes.
that's what. Sir,
Yeah,
yeah, sir, that's what I'm also
I
saying. They're
forgot,
saying
sir.
no, sir.
it's not a part of endotherm. It's not a part of
It's like a type.
decomposition
See,
reaction.
photochemical. What is this?
Yeah,
Electrolysis. They're all
endothermic
part of
reaction.
decomposition.
Endothermic reaction is not a part of decomposition reaction. Wrong.
Said
Exactly. See,
like
actually,
a part means a
please
part of this is
remember
decomposition.
that whether your reaction is decomposition, whether it is displacement, you have to remember that if heat energy is evolved, that's your exothermic, and if heat energy is absorbed, that's your endothermic. Simply.
Should I write delta minus then?
Yeah, you probably should.
Nice background.
Thank you.
Not you. I was talking to myself. He was like, I'm a hop off, and he already actually hop off.
Am I audible right now?
Yes, sir.
Yeah.
Okay, now tell me that which reaction is this one?
Yes, sir.
So your photosynthesis reaction. So can you tell me which reaction it is?
Sir,
Photosynthesis.
photochemical and endothermic. Photochemical and endothermic.
It's exactly your photochemical reaction.
No.
Sir, it's
Photochemical and
it's
endothermic.
not an endothermic.
It is. Sir wrote it
Yes.
right there for endothermic.
Now tell me, okay, I will give you just the reaction. If I will write zinc plus H2SO4, can you tell me whether it is endothermic or exothermic?
Say
But
endothermic.
it's endo, sir.
Endo, sir.
Wait, no, it's not.
Wait, it
It's
is
not.
endo, right?
It's not.
It
It
is.
is an exothermic reaction.
It's not
Yeah,
reaction.
it's exothermic. I know. I remember studying this. Take the.
No, liar.
I said
So you have
exothermic.
to remember that whenever any metal reacts with the acid, so then heat energy is evolved. So that means that reaction is your exothermic.
Oh,
Yes,
okay.
sir.
Tip.
It when you
Yeah,
got
this
heat controlled exothermic.
you have to remember this tip that whenever any metal, for example, let's say if I'm reacting magnesium metal with with hydrochloric acid, let's say HCl. So what will be the product?
Magnesium chloride plus hydrogen
MgCl
plus
plus
delta.
chloride plus hydrogen plus hydrogen gives
Tell me, is it
plus heat
exothermic?
exothermic. Exothermic.
Exothermic.
Exactly.
Exothermic.
It will be also
Exo.
exothermic. Exactly.
So
So note
It's
down
always
this.
metal means exothermic.
Metal and acid.
Yes, metal and acid.
So metal and acids in the sense I can write like nucleic acid. No, not nucleic acid. Nitric
nucleic
acid.
acid.
Sorry, wrong.
Nice.
It's biology. Na?
Oh, stop it, right? You're the reason I'm telling you. Sulfuric acid,
What
carbonic
did I do?
acid, everything will. Shut up. Everything will be exothermic, sir.
Yes.
Everything will be.
Whenever
If
any
reacted
metal
with the
reacts
metal.
with the acid,
If
that
reacted
will
with metal.
always be
No,
exothermic.
wait.
Only if it reacted with the metal.
It's
Have you
like
noted down
any,
this? Shall I move to the
yes,
next
sir.
page?
Yes, sir.
Yes.
Yes,
It's like
sir.
any acid react with any metal is always an exothermic.
No, any metal reacts with any acid only. It's
I said
Yep.
it the way around.
no, you said
Now
yes,
can you
acid.
name, now can you name a reaction in which electricity is used or electricity is absorbed?
Water, decomposition
So
of water.
no. Water
Yeah.
with
Exactly,
H2O with electricity
No,
gives
water with
H2 plus O4.
H2SO4. So water with
No.
H2SO4 in it.
No. Sir,
Water,
2H2O
when we do
plus,
the electrolysis, that is when we pass the electricity through this water, we
But
get H2 plus
shouldn't it
O2.
be H2O plus H2SO4?
No, we just add the few drops of H2SO4 in order to make it conductive. We will only write here the H2O.
so H2SO4 is
No, but it's still
bisulfate.
no H2SO4 is. Wait.
Oh wait, HSO4 is only okay. What is it? What is it?
Sir, but it still contains H2SO4, right, sir?
Exactly. Whenever we do the electrolysis of water, it should be impure. So that's why we actually add the few drops of sulfuric acid in order to make it conductive.
Yes, sir.
Yes. Now, can you name any reaction in which electricity is produced?
Reduced
Yeah,
thunder, lightning.
that will be your redox reaction, isn't it?
Burning of coal.
Redox is.
Sir, burning of coal.
How do you form lightning with that?
How do you-
No, not lightning, electricity.
You form electricity with burning coal.
You don't know, huh?
Don't
How
think,
do you think?
No. You
See,
think
I will
light
tell
shine
you,
with
just
coal,
listen to me. And that whenever there is a
Heat
redox
energy.
reaction, for example, okay, I will tell you, for example, if I will just react zinc with copper sulfate, right?
Yes, sir.
This is a type of displacement reaction, so it will give you zinc sulfate, and what you will get?
Sulfate plus copper.
Copper.
So
Exactly.
exothermic.
So this is a redox reaction. This is a redox reaction. Redox means here both oxidation as well as
Both
reduction
the
takes place.
oxidation
Reduction.
and reduction.
Exactly,
Reduction.
exactly.
Yep.
You are right that what actually here happens is zinc, it actually undergoes oxidation,
So
and
it's a
this
displacement reaction, sir.
exactly, it is a displacement, but it is also a redox reaction.
Also a redox.
Exchange of ions.
Yes.
You will
Yeah,
just
the same
remember
as
that a particular reaction, it can be displacement, it can also be a redox reaction, it can be also exothermic or endothermic. So a particular reaction, it can be any type of reaction. So it is not necessary that if you are having a
But
displacement
Sir,
every
is
single
that-
reaction will have a redox. It's a redox reaction.
Yeah, every
Yeah.
single reaction is a redox
Yeah.
reaction.
Everything will lose and gain hydrogen.
Exactly. Where there is oxidation, there is always reduction. So that means they are taking place simultaneously, and any reaction is a redox reaction. Most of the
It
reactions
doesn't
they
even
are
matter if there is oxygen or hydrogen. So because exchange of electrons can also be redox reaction, right?
exactly because one element it will
any
lose
reaction is a
electron,
redox reaction
and yes,
That's what we
exactly.
say
Every
here.
reaction is a redox reaction.
that has oxygen and hydrogen.
No,
It is
also electron.
It can be
oxygen and
any.
hydrogen. It is
It
not
doesn't matter
necessary.
if it. Yeah.
Those tiny particles is the reason.
If the,
Exactly. When there is actually loss and gain of electrons, so that is also a redox reaction. So oxidation is actually loss of electron, and reduction is gain of electron. I will write it here. Oxidation, it means loss of electron, and reduction means gain of electron. So are you getting?
yes, sir.
So reduction means gain of electron.
Copper sulfate is oxidizing agent.
Yeah, see now this copper sulfate, it undergoes reduction, so therefore it is your oxidizing agent, right?
Oxidizing agent. Yes.
The reason behind oxidation.
And zinc is your reducing agent here.
Yes, sir.
Yes,
Because it reduces.
Yes, exactly,
No,
because it
the
the
helps
reason
us
behind
in
it
reduction of copper sulfate.
reduces.
Shut up.
Reduce.
So this reaction, this is used for the production of electricity. So have you noted down these reactions?
Yes,
One
sir.
second, sir. I'll remember that down.
Okay, you just right.
So what is this reaction name called? Like
zinc sulfate.
This is your
Redox
displacement
reaction.
reaction. You can also call it as redox reaction.
Like exoelectric reaction. Like what is it called?
No, it is known as displacement or redox reaction. No any other name.
Okay, sir.
Yes, sir. Finished, sir.
Okay, then if I will write the next
No,
equation
1
like
second, sir.
sure, sure.
So any redox reaction like produces electricity.
Exactly, yeah.
That means every
So like
reaction produces electricity.
Yeah,
So
because
can you
that's
tell me,
change of electrons, right?
have you heard this rusting of iron?
So
yes,
iron
sir.
plus
Sir,
oxygen
Fe plus
gives iron
O2
oxide.
gives
FeO.
Fe3O4.
Sorry.
Oh wait, I forgot about the water.
Fe2O.
Fe3, Fe2O3.
Yeah.
In Jack's time is what? So this is your
Yes.
rust.
Yes, sir.
So can you balance this?
So what is X, sir?
2
It's like
plus 3.
X is a variable, da. There can
Exactly.
be
X is,
variable amount of
Okay. I
water.
get it.
Don't say that
X
again.
is variable. So X can have any value like 1, 2, 3, etc.
So what do we take?
Yeah,
Yes,
water we
redox.
take X times.
Take it
X
as
times
X.
that means, yeah, because sometimes water moisture it will be in excess, sometimes anywhere it will be in less quantity. So that's why it's variable. We write X times water.
Sir, should we write that down?
Excess what? Can you repeat what you said?
X is variable.
So should we write this down?
Yeah, you just write this. So now can you tell me, is this a redox reaction or not? Rusting
Yes,
of
sir.
iron.
Yes, sir. It is
Yeah.
a redox reaction.
Exactly.
Any
It is also
reaction in the chemistry universe is redox.
exactly. So it's a redox reaction.
Until you can name a reaction where there's no exchange of electrons.
Your brain. So you can
The reactions which take place in the brain, that is the electrochemical reaction, they are also of redox nature.
Yes, sir.
Yes, so you have to remember.
So this is a part of like electricity emitting, right?
Exactly.
So
We
this-
study these reactions in the electrochemistry.
But if every redox reaction emits electricity, so every reaction is electrolysis reaction.
Electrolysis is
Oh,
different,
no.
Ra.
No. Okay. Every reaction emits electricity.
No.
Yes.
Yes.
Why no,
No.
sir?
No. What?
What are you saying?
Why no?
See, whenever there is redox reaction, then electricity will be produced. If there isn't
Sir,
any
like all
redox
Sir,
reaction,
reactions are
every
redox
reaction is a
reaction.
redox reaction, right, sir?
But every reaction is a redox reaction, is what you said. So every
yes, every
reaction
reaction
emits
is a redox reaction, but every redox reaction that will not give you always electricity. For example, if you are just burning this methane here in presence of oxygen, do you get here the electricity?
I don't know,
No,
sir.
no, we don't get the electricity here. We get only the heat energy here.
Oh,
So,
so
but
like
yeah, so that is why you have to remember that from every redox reaction, you will not get the electricity. There should be actually loss and gain of electron, then there will be production of electricity.
so there is loss and gain of electron in that, right?
In which reaction?
So CH4 is the
CH4.
oxidation.
Oxidation.
No, wait.
No?
CH4 is reduction. O2 is oxidation.
Sir, carbon gets reduced and oxidized, sir.
Say it is here your methane, so actually it has got converted to CO2, so that means there is addition of oxygen, so it has undergone oxidation, and this O2 it
As
has
well
got
as
converted.
reduction, sir. It's
Yeah,
got
exactly.
reversed, like.
There is oxidation as well as reduction, so it is a redox reaction, but here you will not get the electricity.
So there are no criterias like for electricity production.
Yeah, there is criteria that actually in order to produce the electricity, there should be a cell, there should be anode, there should be cathode. So here isn't any anode, any cathode, so that's why no electricity will be produced.
So in zinc plus copper sulfate, where is
The
Yes,
anode and cathode?
yes, exactly. Zinc is there, your anode, and copper rod is there acting as
do we
cathode.
know
Here,
what is anode? Like
Oh.
which one is anode?
okay, you don't
Oh,
know
sir,
what is anode
that's
and what is
why
cathode.
they use zinc in battery.
Exactly. We are using zinc and copper there in all types of battery. So now, have you written down this? Shall I rub it?
So,
Yes, sir.
Yes, sir.
Okay, I will next. So now, what I was saying, what is anode and what is cathode? So can you define what is anode?
anode is positive.
That's the positive terminal, sir. Cathode is the negative terminal.
Positive terminal.
But remember like this, that anode is that electrode on which oxidation takes place.
Oh yeah, oxygen gets added.
On which oxidation takes place, right?
One second, I'll write this.
Yes, sir.
You just write it down. And what is cathode?
Reduction
Electrode
takes place.
on which reduction takes place.
Exactly, electrode on which reduction takes place. So that is your cathode. So what I was just saying, okay, now I will tell you in detail so that you can understand that how electricity gets produced and what are the requirements. So this was our reaction. So it was the formation of zinc sulfate and copper. So actually see what we are doing here. We are just having one container, or you can say the one beaker, and we are having the another one. So these are actually the two half cells. Now in the one, we are just dipping zinc rod in zinc sulfate solution. So this is my rod of zinc, which will act as anode.
Sulfate solution.
Exactly, we are just putting zinc rod in zinc sulfate solution.
So is it copper sulfate solution?
No, it is here zinc sulfate. I will tell you, you just to focus on this. So next electrode we are having here in another half cell. This is my copper, and this is just to put in copper sulfate solution.
Oh, it's zigzag.
Yeah, so it is just like this. So zinc in zinc sulfate and copper in copper sulfate. Now what we are doing here, so this is your zinc, so it is then connected to the,
Copper.
it is now connected to this voltmeter, or the, not the battery. Here you will just, what you will see, that this zinc, it will lose electrons. Zinc will just lose electrons, so these electrons, they will flow through this wire. So it's a metallic wire here. And now electrons, when they will flow from zinc towards the cathode, towards this copper electrode, so this voltmeter, it will show you the deflection. So this deflection indicates that current is flowing. So this is how actually current flows in this cell, in this battery. So the reaction generally we represent like this, that is zinc plus CuSO4, it gives you zinc sulfate plus copper. So got it now?
Yes, sir.
So write down this. So this is how, so what is the criteria where we
Sir,
can
should
say
we
that,
draw that?
yeah, you have to draw this. That is why the reaction which I have written down earlier, that is methane plus O2, that gives you CO2 plus water. So that will not produce electricity. For electricity production, there should be a redox reaction, and there should be anode, there should be cathode, isn't it? Like this.
Yes, sir.
Exactly. So can you once again tell me any such reaction in which sound energy is actually utilized? Is there
Sir,
any
it's
reaction?
carbon. Sir, carbon plus oxygen. No.
Ethyne.
Hyd-
Ethyne.
Sir,
Exactly. It is the ethyne. So
Ethyne.
that's
produces a
C2H.
pop sound.
Yeah, exactly. So when we just give the sound energy to this, what it gets decomposed
Sir,
to.
it is also a photochemical reaction because it absorbs sunlight. I mean, needs sunlight.
So it gives you carbon and hydrogen. Like, is it balanced?
Yes, sir.
Yes, sir.
Yes,
It
sir.
is.
Yes.
Exactly, it is
So
balanced.
it is also as sunlight energy, right? So, I mean sunlight also. So it's also like
Yes,
a photochemical.
whenever we have any reaction which absorbs the sunlight, so that is definitely photochemical reaction.
Yes, sir.
This is also a photochemical, right? So also
Yes.
photochemical and sounds.
Yes, I have already told you that a particular reaction that can be 2-3 types. So sometimes a reaction can be exothermic, the same reaction can be displacement, the same reaction can be redox reaction. So you have to remember this. So have you written down this?
Yes,
Yes,
sir.
sir.
Yes,
I'm just
almost
drawing
1
that
second.
diagram.
Yes.
Yes, sir. That's taking so much time. Yes, sir. Finished, sir.
One
Okay,
second,
then if
sir.
I will write, wait,
1
if
second,
I
sir.
will just
No.
write, okay, no problem.
Don't, sir. Don't, sir. Don't, sir.
Yes. Done. Clear it. Clear.
Why are you so happy if we fail?
Yeah.
I'll get first rank
You
again.
should not be friends with Nitish Kongwell.
Who is?
What do you mean, Ra? I only called you today.
By the way, Mitran's watching this.
What?
Oh, you
Mitran's
said
Why is
watch
he
the
watching
videos.
this?
What?
watching this class.
What do you know? Oh, is you
From
sending
the
the
start.
videos?
Yeah, no,
Everyone cancels something.
no, I'm sharing in Discord. Right,
Sir,
You
look
can't.
at this,
I know
sir.
you
This
can't.
guy is- No,
Hey, I know you
can.
can't.
Then
Right?
what
Hey, he's
the-
joking.
You
That you.
can, Ra.
Have you now written
I
down?
sent it to my phone when I was absent.
That's only if you have the learning room app and if you're registered in
Yeah,
this
he has
batch.
the learning room app.
You have to be registered in this batch, Ra.
Something
He's not
is
a
there.
part of the batch. Yeah.
Be quiet,
In
be
order
quiet.
to view it, he needs to be a part of the batch.
Yeah.
Idiot, I'm talking about he's in Discord right now and I am sharing my screen.
Sir, you have to go complain to his parents. This guy is not.
No, no need.
Sir, you
Hey,
can go
no.
to the next bit, sir. Sir, you can continue.
Hey, just
We are
sir, double the fees.
No, I am not.
Recording. Just be quiet.
Just now focus on the study. So what I was saying, for example, if I will write a reaction like this, if I'm having sulfur dioxide reacts with oxygen, it forms the sulfur trioxide. Can you
Yes, sir.
balance this?
So, 3O2 gives 2 SO3. Oh, wait. Okay.
Is it balanced?
So,
Oh, yes, it balanced.
yes, sir, it is balanced, sir. I said it
Okay, so
first.
can
Hey,
you tell
what
me?
do you mean?
Can you tell me which reaction it is?
Sir,
It's a synthesis reaction. It's a synthesis reaction. It's a synthesis reaction. I said
Exactly.
first. It's
Exactly. Synthesis reaction. Exactly. Or what we call it also, it is also known as
Combination reaction.
reaction. I said first.
exactly combination reaction. Correct.
Now, can you hear me, sir? Am I audible?
Yeah, you are audible.
Just checking.
So have you now written down this?
Page, sir. Yes, sir.
Yes,
Don't
sir.
have it.
Okay, I will now go to the next page. So tell me, I will just write here the reaction and you have to tell me which type of reaction it is, right?
Yes, sir.
Okay, if I will write PbNO3 whole twice, it's your lead nitrate. And if I will treat it with potassium iodide, and this gives me the lead iodide, that's PbI2. This is yellow
Sir, double
PPT,
displacement reaction.
What?
yellow
No,
Let
precipitate.
him finish it. Let him finish it.
And similarly, I will get
Wait,
here
I
the
wrote
potassium
this. I wrote
nitrate.
this.
Okay, now can you tell me, is
So
it
it's a
balanced?
double. It's a,
Can you
so
tell
it's a
me
double
first of all,
displacement reaction.
or not?
Sir, what the?
Sir, what
is
did you
this?
ask? Wait. What did you ask?
First, tell me, is it balanced or not?
No, sir, it's not.
It's
Okay,
not
balanced.
balanced.
Tell me how to balance.
Sir, 2KNO3.
Sir, 2KNO3 and 2KI.
and
2KI.
Yeah, 2K and 2KNO3. It's balanced now. And I was the one who said it first.
yeah.
You only said 2KNO3. I only said 2KI.
Yeah, that's what I said.
No, you said after everyone said.
No, I said 2K and 2KI.
It is a
Now
double.
tell
Shush,
me.
shush.
Now tell me
Chup
which type of reaction it is.
Double D.
It's a double displacement reaction. I said first.
Okay, it is a double displacement reaction. Okay, now can you tell me, is it any other type of reaction?
It's a redox reaction.
Hey, that's
Double
everything.
It's a
displacement
chemical
reaction.
reaction.
It is
Yeah,
definitely a
chemical.
chemical reaction, but tell me the reaction which you have studied. So can
So,
you tell me, is it a precipitation reaction?
precipitation reaction, sir.
Precipitation reaction.
Oh, yeah.
Exactly, it is a precipitation reaction because here we are getting the precipitate of lead iodide, that is yellow PPT, yellow precipitate.
Sir, it produces iron because lead and potassium
That's a nickel.
or cathode anode. I think it produces electricity, right, sir?
Yeah, because it's a
No,
redox reaction. So how does it not?
No, only sir said all redox reactions emit electricity.
I told that
They
all
do.
redox reactions will not produce the electricity.
Okay, so
So, so this one doesn't produce electricity.
No.
So can you
This is
tell
the-
like the circumstances for a chemical reaction to emit?
How do we find it out, sir?
Yeah, that's what I
Exactly. See, you have to study it in detail in the higher classes. There should be anode, there should be cathode, and there should be easily one metal should easily lose the electron, another should easily gain the electron. Then we can produce the electricity.
So lead
How
easily
did we
loses and potassium highly gains, right?
yeah,
Potassium
so,
loses. Potassium cannot gain here. Potassium is highly
Oh.
reactive metal. It's
Yeah.
electropositive. It loses electron.
yes, so potassium
Okay,
will
sir.
and
Lead cannot
P
easily
will
gain. That's why lead cannot easily gain here the electron. So that's why here electricity will not be produced.
So if it's
Is it because
potassium,
is it because potassium is
See, I have told you that, for example, if you are having this zinc and it reacts with you copper sulfate, this type of reaction, it is used to produce the electricity because here zinc loses easily the electron, isn't it? Zinc here loses easily electron and this copper can easily gain that electron. Are you getting?
yes, sir.
Yes, sir.
Yeah, so that's why it is possible that we can use this redox reaction in in the formation of electrochemical cell. So you will electrochemical cell, right?
Yes, sir. So zinc is the anode and copper is the cathode.
Cathode. Yes.
Zinc is the anode exactly and copper is the cathode.
Okay, sir.
I have just shown you the diagram of this type of electrochemical cell in which this reaction redox
sir.
reaction takes place. Exactly. Okay, now if I will just write another reaction here.
So next phase.
So for example, if I'm having this iron sulfate and I'm heating it, it gets converted to Fe3O4 plus SO2 plus SO3. So can you tell me what type of reaction it is?
So it's a neutralization reaction.
It is
Sorry,
a
it's an
thermal
endothermic
decomposition.
reaction. It's an endothermic reaction.
It is thermal
No.
decomposition reaction.
So, but that triangle symbol is there.
But you said decompose. Oh, okay.
Thermal decomposition reaction. Are you getting?
Yes, sir.
Thermal
Okay,
decomposition.
I get it.
Sir, there is sulfide.
So in thermal decomposition, it has to be only absorption of heat energy, right? Not not evolution
That's a
of heat.
totally different thing.
In thermal decomposition reaction, heat is
It's
involved.
endothermic.
Heat is needed
Endothermic.
for
It's
the thing is.
definitely it is endothermic. It's
Okay.
also endothermic.
Heat is need. Yeah, that's what I said. It's
So
also
the-
endothermic.
No, I mean can be, but sir, in this thermal decomposition
Wrong,
means
Nitish.
it needs heat to decompose, right, sir? It
What?
does not evolve or absorb heat, right, sir? It only
It
needs
absorbs heat. It absorbs heat. Heat is here required for the decomposition, so
See,
that's
it
why
is
it's
absorbing heat.
Wait, I shut up. I'm asking, sir.
I
Yes, sir.
won't.
Sir, like in electrolysis, it doesn't emit, like it absorbs heat, but like not in after product, right, sir. It only needs it in the reactant side, right, sir.
exactly. But these reactions are also treated as endothermic because we are just giving the heat energy. Some heat energy is absorbed and some is used to break the bond, to break this substance.
So all thermal decomposition are endothermic.
Exactly. Yes, they are your endothermic reactions.
Said you were wrong. You said I was wrong, Nitish. You were wrong.
When I said you were wrong, did you say we agreed? I know, right?
Hey, stop fighting like
So you
babies.
can
Stuff.
continue. So you can continue, sir.
Are you the
note it down?
parent, Kungal?
Yes, sir, I finished writing, sir.
Done, sir.
Sankalp
Okay,
is
then
always
Done,
talking
sir.
and not finishing.
Let's
I
practice
finished, yeah.
another question.
So, yes, sir.
Okay, now let me write another one here, reaction, and you have to tell me what type of reaction it is.
Use my brains.
So if I will write this potassium, it reacts with chlorine and it forms with the potassium chloride.
Sir,
So it's a synthesis reaction. It's a synthesis reaction.
Which reaction?
Combination.
Synthesis reaction.
Exactly, it is a combination reaction,
That's what.
right?
what do you mean you said first, Sankalp? Ask anyone. Except
Combination
yourself.
or synthesis reaction, right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now if I will write the next reaction, for example, let's say it's my HCl. It reacts with lithium hydroxide. It gives me lithium chloride plus water. So what type of reaction it is?
So it's a
Sir, sir.
neutralization reaction.
It's a
Yeah,
displacement
exchange
reaction.
of
Double
ions.
displacement. Double
It's a
displacement.
neutralization reaction. It's an
Neutralization.
acid salt.
I forgot.
Ions,
I forgot.
ions are exchanged.
See,
Yeah.
I know. I
No,
know.
no, no.
I got
See,
it.
actually, what you had to see
no,
here,
it's
that
a
in
salt
the product
and
we are having
a base.
Acid and water.
lithium chloride, it is your salt, and water, it is the water here, and we are having the acid and base, it is your acid HCl, and base is this one. So when acid reacts with base, it is your neutralization reaction.
Yes, sir.
Yes.
Got it now?
Yes, sir.
Yes, sir. So it's balanced as well.
Okay, now can you tell me, is it a redox reaction? Okay, you have to tell me here which has actually undergone a reduction and which has actually undergone oxidation in this reaction.
Magnesium
Sir,
has
magnesium has
reduction.
Magnesium has undergone oxidation.
You are the last one to say it.
But
Exactly.
no one completed it. No one completed it.
So see, actually here magnesium, it has undergone oxidation, and oxygen, it has undergone reduction. So magnesium is your which agent?
I was first.
It is
Sir,
your reducing
it's
agent.
reduction agent.
Reducing
Oxygen is
agent, and
our
oxygen will be your
or
oxidizing agent.
oxidizing agent, correct?
Yes, sir.
So is it now clear to all of you?
Yes,
yes,
sir.
sir.
Yes, sir.
Yes, with this we have just completed this unit, but we will still practice more questions in the next class, and I hope
We finished
The
this
next
chapter.
class is
that you will revise each and everything from this, right?
Sir,
Getting
next
what I
class is the
told?
last class before summer holidays.
chapter.
Yeah, we have finished this chapter. That is your second chapter, and
Yes, sir.
Sir,
and I
next is
hope that
water.
yes, yes. Next is our water chapter. Yeah.
So then
Yes,
when
sir.
do we do hydrogen chapter, sir?
After water.
We will go accordingly, we will go in sequence. First we have completed the first two chapters, then we will similarly study the water, then we will move ahead. So that means we will move in the sequence wise. We will discuss these units one by one. So I hope that you will revise each and everything because you are gonna to face the exam. And let's see the various problems and other practice questions in the next class. Until that, wish you all the way best. So have a nice day ahead.
Thank you, sir. Bye,
Thank you,
sir.
Thank you,
sir.
sir. Bye, sir.
Bye.
Okay.